Assalamu alaikum dear students, welcome back to my YouTube channel, and that is Zahoor sir's math classes. In the previous class we have completed our exercise of NCERT book, that is exercise 7.3, and there we have used the trigonometric identities in order to reduce the given integrals into their standard forms, and after that we have integrate the functions, we have obtained their antiderivatives or primitives by using a proper trigonometric identity which was suited in that in every question, and in order to reduce that, and after reducing we have used the standard results in order to find their antiderivatives. That was all about exercise 7.3. The next step that we are going to, and that is some special integrals. Some special integrals are there, and we are going to prove them, as well as we are going to use them in the next exercise, and that is exercise 7.4 of the same NCERT book. Here we are in a position to discuss some special integrals. So here lies the topic, some special integrals. The first special integral that we are going to discuss, and that is, and these special integrals, they are in the form of a theorem, and the statement of the theorem is, or we can say that we can have a proof of these special integrals. So it is in the form of a theorem. So prove that first one, integration of 1 divided by x square plus a square into dx, and that is equal to, ये हमने स्टैंडर्ड रिजल्ट्स में भी पढ़ा था, स्टैंडर्ड इंटीग्रल्स में भी पढ़ा था, लेकिन इन्हें हम प्रूव भी कर सकते हैं. तो कैसे? 1 divided by x square plus a square, and its integration is 1 divided by a tan inverse of x divided by a plus c, the constant of integration. The first most integral, and that is a special integral, 1 divided by x square plus a square, or it can be of the form 1 divided by a square plus x square dx, and that is equal to 1 by a tan inverse x by a plus c. The second special integral that we are going to prove here is integration of 1 divided by x square minus a square into dx, and that is equal to, its antiderivative is 1 divided by 2a log of mod of x minus a divided by x plus a plus c, the constant of integration. The third special integral that we are going to prove is integration of 1 divided by a square minus x square into dx, and its integration is 1 divided by 2a again log of mod of a plus x divided by a minus x plus c, the constant of integration. The next, that is fourth standard integral that we are going to prove, is integration of 1 divided by square root of x square 1 divided by square root of a square minus x square dx, and that is equal to sine inverse of x divided by a plus c. The fifth special integral that we are going to discuss is integration of 1 divided by square root of x square plus a square into dx, and that is equal to log of mod of x plus square root of x square plus a square plus c, the constant of integration. And finally, the sixth special integral, and that is integration of 1 divided by square root of x square minus a square into dx, and that is again equal to log of mod of x plus square root of x square minus a square plus c, the constant of integration. The fifth special integral and the sixth special integral, they are just the mirror images of each other, because here in case of we have in between x square and a square we have plus sign, and here we have minus sign, and it is equal to log of mod of x plus that is equal to log of mod of x plus स्क्वायर रूट यहाँ पे भी वहां पे भी x स्क्वायर a स्क्वायर वहां पे भी यहाँ पे भी, लेकिन यहाँ पे स्क्वायर रूट के अंदर x स्क्वायर प्लस a स्क्वायर है, वहां पे स्क्वायर रूट के अंदर जो है that is x स्क्वायर minus a square. So these are the 6 special integrals that we are going to prove, as well as that we are going to use in the next exercise, because the next exercise, that is 7.4 of NCERT book, is wholly and solely based upon these 6 special integrals, right? These 6 special integrals we have already discussed in the standard integrals, but here we are going to prove them as well. So lies the proof of first most standard integral, and that is 1 divided by x square plus a square dx is 1 by a tan inverse x by a plus c. So here lies the proof of first standard integral. Here lies the proof of first standard integral. So here it is the proof. So we have to prove that integration of 1 divided by x square plus a square dx is equal to 1 by a tan inverse x divided by a plus c, the constant of integration. So we have integration of 1 divided by x square plus a square into dx. Look, अगर हम यहां पे x का अगर हम इसे सॉल्व करेंगे बाय सब्स्टिट्यूशन मेथड, अगर हम x को सपोज पुट करेंगे a tan थीटा, तो x स्क्वायर क्या आएगा, a स्क्वायर tan स्क्वायर थीटा, a स्क्वायर और a स्क्वायर कॉमन आएगा, बचेगा 1 प्लस tan स्क्वायर थीटा एंड दैट इज sec स्क्वायर थीटा. सो जब फिर इसकी ये जो इंटीग्रेशन डिफरेंशिएशन यहां पे करेंगे सब्स्टिट्यूशन मेथड अप्लाई करने के बाद, तो वहां पे आएगा ऑब्वियसली sec स्क्वायर थीटा. सो डेफिनेटली ये इंटीग्रल सॉल्व होगा बाय पुटिंग x इज इक्वल टू a tan थीटा. सो हियर वी आर गोइंग टू प्रोसीड लाइक दिस. पुट x is equal to a tan theta, so that since here it is the variable is here theta, a tan theta, so since the variable is theta, that means we are going to differentiate this equation both sides with respect to theta, because the variable here is and that is theta. So in differentiating both sides with respect to theta, we get dx divided by d theta, because we are differentiating x with respect to theta, so dx by d theta, and that is equal to a is constant will come out of the derivative, and the differentiation of tan theta is sec square theta, because the derivative of tan theta is nothing but sec square theta. So implies this can be further written as, yes, separate the variables because there we have theta, and ये theta को वहां पे ले लो, तो क्या बचेगा, dx must be equal to, yes, a sec square theta d theta. Is that clear? So therefore our original integral is integration of 1 divided by x square plus a square into dx can be written as integration of 1 divided by, yes, x square. Put the value of x. What is that? A tan theta. So x square must be equal to a square tan square theta plus a square is as it is, that is a square, into dx. The value of dx is a sec square theta d theta. There it comes. a square कॉमन आएगा, 1 प्लस tan स्क्वायर थीटा इज sec स्क्वायर थीटा, ये वाला sec स्क्वायर और ये वाला sec स्क्वायर कैंसिल हो जाएगा ऑब्वियसली, क्योंकि एक मल्टीपल में है एक डिवाइड में है, तो ऑब्वियसली द रिजल्ट द integral must be reduced to the standard form, and when it is reduced to the standard form, obviously we can locate its antiderivative. So that is further equal to, yes, integration of 1 divided by ए स्क्वायर यहां पे भी, ए स्क्वायर यहां पे भी, ए स्क्वायर को कॉमन लेके आओ, क्या बचेगा 1 प्लस tan स्क्वायर थीटा इंटू ए sec square theta d theta. Is that clear? So that is further equal to अब देखो यहां पे एक a यहां पे है, एक a यहां पे है, मतलब यहां पे a स्क्वायर है, यहां पे a है, तो एक a और एक a कैंसिल होके यहां पे बचेगा a. 1 डिवाइडेड बाई a जो है वो कांस्टेंट है, इंटीग्रल में से बाहर आएगा, क्योंकि एक फंक्शन के साथ जब एक कांस्टेंट मल्टीपल होता है, so that remains unaltered under the operation of integration as well as differentiation, so it will come out of the derivative as well as out of the antiderivative. So 1 divided by a integration of, yes, 1 divided by, यहां पे बचेगा 1 plus tan square theta and that is sec square theta into, यहां पे क्या बचेगा sec square theta d theta, so sec square theta d theta, and that is further equal to 1 divided by a integration of sec square theta, वहां पे बचेगा 1 d theta, and that is further equal to 1 divided by a, yes, by proper substitution method of x is equal to a tan theta, the given standard, the given integral which was not in its standard form, and by a proper substitution of x equal to a tan theta, it has been reduced to the standard form, right? So 1 divided by a, the integration of 1 dx is obviously equal to x, so integration of 1 d theta is obviously is equal to theta plus c, the constant of integration, and that is further equal to 1 divided by a. Now we have to locate the value of this theta, because the original integral is in the variable lies, and variable of integration is there, and that is x, right? So we have to change this theta into x. Now since we have taken x is equal to a tan theta, since x is equal to a tan theta implies a यहाँ पे मल्टीपल है, इसमें डिवाइड होगा तो x divided by a must be equal to tan theta. Operating tan inverse or using the injectivity of inverse tangent function in the restricted domain, यहाँ पे भी tan inverse, यहाँ पे भी tan inverse tan बनेगी identity function, यहाँ पे आएगा tan inverse. So obviously tan inverse of x divided by a must be equal to theta, because using the injectivity of tan inverse function, when x1 is equal to x2, then obviously tan inverse of x1 is equal to tan inverse of x2. Why? Because tan inverse in its restricted domain is obviously 1 1. We have studied these concepts, we have learned these concepts in inverse trigonometric functions. So tan inverse of x by a must be equal to theta. So instead of theta, we can write tan inverse x by a. So instead of theta, there lies tan inverse of x divided by a plus c, the constant of integration. So the integration of the antiderivative of 1 divided by x square plus a square dx is nothing but 1 by a tan inverse x by a plus c, and here 1 by a tan inverse x by a plus c, and q e d, we have proved the result. So q e d, quad erat demonstrandum, hence the demonstration of that thing that we have to prove. जो हमें प्रूव करना था हमने कर दिया. So QED, it's a Latin phrase, as I have mentioned in the earlier classes, means quad erat demonstrandum, right? So the proof of first special integral. Now we will sit upon to the next, we will switch to the on to the next standard, next special integral, and that is all about the next special integral that we are going to prove here is, and that is second one, and that is integration of, we have to prove that integration of 1 divided by, rather previous integral में हमने प्रूव कर रखा है कि इंटीग्रेशन ऑफ 1 डिवाइडेड बाय x स्क्वायर प्लस a स्क्वायर dx must be equal to 1 divided by a tan inverse of x divided by a plus c, right? तो इसी में हम एक और रिजल्ट जो है, इसकी कोरोलरी जो है वो भी प्रूव कर सकते हैं. कैसे? अगर हम यहां पे x को हमने प्रीवियस रिजल्ट में जो हमने थ्योरम प्रूव कर रखी है यहां पे, उसमें हमने x को पुट किया था a tan थीटा। अब अगर कोरोलरी में हम x को पुट करेंगे a cot थीटा, राइट? सो ऑब्वियसली ये रिजल्ट जो बनेगा ये बनेगा इंटीग्रेशन ऑफ -1 डिवाइडेड बाई एक्स स्क्वायर प्लस ए स्क्वायर, एंड दैट मस्ट बी इक्वल टू 1 बाई ए कॉट इनवर्स ऑफ एक्स डिवाइडेड बाई ए प्लस सी. So another result, another special integral that we can derive from the first result that we have proved earlier here, and that is corollary, means if we put x square is equal to a cot theta, so obviously we will get another standard integral. You can have a try. We can get another special integral, and that is -1 divided by x square plus a square must be equal to 1 by a cot inverse of x by a plus c. So you can have a try and you can have the result of this another special integral. Now lies the second standard integral, second special integral that we are going to prove here, and that is we have to prove that integration of 1 divided by x square minus a square into dx. Integration of 1 divided by x square minus a square into dx, and that is equal to, yes, 1 divided by 2a log of mod of x minus a divided by x plus a plus c. A special integral 1 divided by x square minus a square dx, and that is directly equal to 1 divided by 2a log of mod of x minus a divided by x plus a plus c. This result we are going to prove here, and here lies the proof. Here lies the proof of this thing, and in the proof we have integration of 1 divided by x square minus a square into dx, and that can be written as integration of 1 divided by, since in the denominator we have a square minus x square, treat x as a and small a as b, so it is obviously a formula, and that is a square minus b square, and we know this is a familiar formula. We know that its value is a minus b into a plus b, and that is equal to x minus a into x plus a, because a square minus b square is a minus b into a plus b, so x minus a into x plus a into dx, and that's equal. Now this can be substituted in the form, you can have a look here, and that is integration of 1 divided by x minus a 1 divided by x into x plus a can be written as 1 divided by x minus a minus times 1 divided by x plus a whole dx. ध्यान रखना, 1 divided by x minus a into x plus a can be written as 1 divided by x minus a minus 1 divided by x plus a. अब इसको सिंप्लीफाई करके देख लेते हैं इसमें क्या हुआ है. तो सिंप्लीफाई कर दो, चूंकि बीच में सबट्रैक्शन है तो क्रॉस मल्टीपल होगा. x plus a 1 हजार, and that is x plus a, right? Minus x minus a 1 हजार, and that is minus x plus a, divided by x minus a into x plus a, that is x minus a into x plus a. Is that clear? Now it is here minus x plus x cancel होगा. a plus a is 2a divided by x minus a into x plus a, right? 2a divided by x minus a into x plus a. Is that clear? So this can be written as, चूंकि हमारे पास था 1 divided by x minus a x plus a, 1 divided by x minus a x plus a, लेकिन इसको जब सिंप्लीफाई करेंगे वहां से मिलेगा 2a, मतलब 2a मल्टीपल हुआ है. 2a जब मल्टीपल हुआ है 2a को बाहर डिवाइड भी कर देंगे, ये वाला 2a कैंसिल होके रिमेनिंग जो रिजल्ट है यही बचेगा 1 divided by x minus a into x plus a, and that is further equal 1 divided by 2a into, now look here, बीच में सब्ट्रैक्शन है, सो ऑब्वियसली जब एडिशन और सब्ट्रैक्शन से कनेक्ट होती है दो फंक्शंस, तो ऑब्वियसली इंटीग्रल जो है, प्रॉपर्टी ऑफ इंटीग्रल यही है कि ये सेपरेट हो जाता है। सो सेपरेटली अप्लाई कर दो 1 डिवाइडेड बाय x माइनस a dx माइनस टाइम्स इंटीग्रेशन ऑफ 1 डिवाइडेड बाय x प्लस a इंटू dx। इज दैट क्लियर? This can be further written as 1 divided by 2a into, now look here, this is obviously a standard integral because integration of 1 divided by x dx is directly equal to log of mod of x। अब instead of x हमारे पास है x minus a, तो यहां पे 1 divided by x minus a की इंटीग्रेशन क्या बनेगी फिर, log of mod of x minus a, so it is equal to log of mod of x minus a माइनस टाइम्स 1 डिवाइड बाय x प्लस a की इंटीग्रेशन क्या आएगी, जब 1 डिवाइड बाय x माइनस a की आएगी log ऑफ mod ऑफ x माइनस a, सो ऑब्वियसली 1 डिवाइड बाय x प्लस a की इंटीग्रेशन क्या आएगी, दैट इज log ऑफ mod ऑफ x प्लस a प्लस c द कांस्टेंट ऑफ इंटीग्रेशन, एंड दिस कैन बी फर्दर रिटन एज 1 डिवाइडेड बाय 2a into log of mod of x minus a minus times log of mod of x plus a. So obviously this is a formula log m minus log n. Treat x minus a as m, x plus a as n. So log m minus log n. It is log m divided by n. So it is 1 divided by 2a log of mod of, yes, m divided by n, that is x minus a divided by x plus a plus c, the constant of integration. So we have obtained the integration of 1 divided by x square minus a square, and that is directly equal to 1 divided by 2a log of mod of x minus a divided by x plus a plus c, 1 divided by 2a log of mod of x minus a divided by x plus a plus c, that we have proved here. So hence QED, quadrat demonstrandum, the proof of second special integral, right, that we have discussed earlier. Now next we have the proof of third special integral. The third special integral lies there, and that is we have to prove that integration of 1 divided by a square minus x square into dx, and that is equal to 1 divided by 2a log of mod of a plus x divided by a minus x plus c. The third special integral that we are going to prove here is integration of 1 divided by a square minus x square dx, and that is directly equal to 1 by 2a log of mod of a plus x divided by a minus x plus c. Is that clear? So here lies the proof of this special integral. They are pretty simple. We have integration of 1 divided by a square minus x square into dx can be written as integration of 1 divided by a square minus x square. Treat a as like this, a square, and this one as b. So it is the formula a square minus b square, which is a minus b into a plus b. So a minus x into a plus x into dx. जैसे हमने प्रीवियस थ्योरम में इस इंटीग्रल को, इस टर्म को, इस इंटीग्रैंड को सुप्लिट किया था, इसी तरह इस इंटीग्रैंड को भी हम सुप्लिट कर देंगे. कैसे? कैन बी रिटन एज इंटीग्रेशन ऑफ 1 डिवाइडेड बाय a माइनस x प्लस 1 डिवाइडेड बाय a प्लस x होल dx. अब देखो, अब आप देख लो, ये सुप्लिट करके हमें, ये सुप्लिट जो है हमने कर दिया, इसमें से हमने एक्स्ट्रा क्या किया या इसमें ऐड क्या हुआ. तो बीच में चूंकि एडिशन है, क्रॉस मल्टीपल कर दो, a प्लस एक्स 1 दैट इज a प्लस एक्स प्लस टाइम्स a माइनस एक्स 1 एंड दैट इज प्लस a माइनस एक्स डिवाइडेड बाय a माइनस एक्स इंटू a प्लस एक्स एंड दैट इज a माइनस एक्स इंटू a प्लस एक्स, राइट? और प्लस x minus x will cancel out, a plus a, so the result is actually 2a divided by a minus x into a plus x, right? 2a divided by a minus x into a plus x, पर एक्चुअल में हमारे पास क्या है, 1 divided by a minus x into a plus x, so 2a इस कंडीशन में, इस जो हमने सुप्लिट किया है ये, इसमें 2a मल्टीपल हो रहा है, जब 2a मल्टीपल हो रहा है उस 2a को बाहर पहले ही डिवाइड कर लेंगे, so 1 divided by 2a. Is that clear? So this can be further written as 1 divided by 2a. Yes. अब बीच में चूंकि एडिशन है तो इंटीग्रल ऑब्वियसली सेपरेट होगा, so integration of 1 divided by a minus x dx plus integration of 1 divided by a plus x dx, and that can be written as 1 divided by 2a into, yes, integration of 1 divided by a minus x, that is obviously equal to log of mod of a minus x plus times log of mod of a minus x plus times 1 divided by, rather यहां पे जो a minus x का जो ये जो इंटीग्रेशन है, अगर हम देखते 1 डिवाइडेड बाय a माइनस एक्स का जो मतलब अगर हम डिफरेंशिएट इसे करते तो डिफरेंशिएशन में मल्टीपल होता -1, डिफरेंशिएशन में मल्टीपल होता -1, लेकिन वी आर डीलिंग विद द इंटीग्रेशन, सो यहां पे डिवाइड होगा -1, सो लॉग ऑफ मॉड ऑफ a माइनस एक्स डिवाइडेड बाय -1, और वो डिवाइड -1 जो है, माइनस साइन जो है वो हम यहां पे ले लेंगे, माइनस टाइम्स लॉग ऑफ मॉड ऑफ a माइनस एक्स, और प्लस टाइम्स 1 डिवाइड बाय a प्लस एक्स का इंटीग्रेशन क्या आएगा, ऑब्वियसली लॉग ऑफ मॉड ऑफ a प्लस एक्स, और प्लस आएगा c द कांस्टेंट ऑफ इंटीग्रेशन, एंड दैट इज फर्दर इक्वल टू, अब ये माइनस कहां से आया, 1 डिवाइड बाय a माइनस एक्स है, a का वो जो कांस्टेंट है उसको छोड़ो, माइनस एक्स का जो -1 डिवाइड होगा उसी को हमने, -1 डिवाइड था उसको हमने यहां पे लिया है, माइनस टाइम्स लॉग ऑफ मॉड ऑफ a माइनस एक्स प्लस लॉग ऑफ मॉड ऑफ a प्लस एक्स प्लस c, एंड दैट इज इक्वल टू 1 डिवाइडेड बाय 2a, 1 डिवाइडेड बाय 2a, यस, log of mod of a minus x plus log of mod of a plus x. अब log of mod of a plus x जो है इसको हम ट्रीट करेंगे एज m और इसको ट्रीट करेंगे एज n. So log m minus log n, obviously log m divided by n. So that is equal to log of mod of what is m, a plus x divided by what is n, a minus x, or plus c the constant of integration. So the result is 1 divided by 2a log of mod of a plus x divided by a minus x plus c, and that is 1 by 2a log of mod of a plus x divided by a minus x plus c. यही प्रूव करना था, hence proved means QED quad erat demonstrandum. So we have proved the 3 special integrals here, and similarly for the same procedure you can yourself prove the rest 3 special integrals that we have discussed earlier. And these special integrals that we are going to use in the next exercise, and that is 7.4. But before that you have to prove the next 3 special integrals. You can have a try, और अगर नहीं आ रहे आप वीडियो में कमेंट कर लेना, और मैं वो 3 जो नेक्स्ट स्पेशल इंटीग्रल्स हैं उनको भी, उनका प्रूफ भी आपको यहाँ पे दिखा दूंगा. वो प्रीटी सिंपल है, जस्ट यू हैव टू फॉलो द प्रोसीजर. वही प्रोसीजर जो हमने यहाँ पे प्रूव कर यहाँ पे यूज किया है इन ऑर्डर टू प्रूव दीज 3 स्पेशल इंटीग्रल्स, वही प्रोसीजर आप वहां पे फॉलो करोगे, और बिल्कुल उसी तरह उन 3 स्पेशल इंटीग्रल्स का प्रूफ आप कर सकते हो. सो यू कैन हैव अ ट्राई, and this is the building material I think for the next exercise 7.4. So we should have some fun with the questions of the next exercise, but in the next class.